Hello everyone. I welcome you all in today's session of computer algorithms. I welcome you all in this first lecture of this course, computer algorithms. Today basically we are going to discuss the fundamentals of this course, why we are studying this course, what is the objective of this course, what you are going to learn by understanding the computer algorithms. Now, computer algorithm is a very important subject in the study of computer science. If you want to be a good programmer, you must uh, be familiar with computer algorithms. You can be a programmer by learning any programming language like Python, C, C++, Java, any language you can learn and you can be a programmer. But in order to become a efficient programmer, a good programmer, you need to have understanding of three things. One is programming language, the second is data structures, and the third is computer algorithms. So now this is the third step of moving toward the efficiency. Already you have learned programming language in Java and C, C++ in your previous semesters. You already finished the course data structures. Now this is the third part, computer algorithms, that makes you an efficient programmer. So let's see what is all in the computer algorithm course. Okay, so uh, we have already familiar with this term algorithm, and you have been hearing this term algorithm for a very long time. In fact, algorithm is something that we are using for a very long back. Uh, you heard of the algorithm like GCD, greatest common divisor. This is one of the very old existing algorithm which nowadays also we are using it. It was proposed somewhere in 300 BC. It is proposed by Euclid, who is also known as the father of geometry. So algorithm is something that have been in place for a very long time. But the word algorithm is coined in the 9th century, somewhere in the 880, by a Persian mathematician. He is also an astronomer, and his name is Abu Zafar Muhammad ibn Musa al Khwarizmi. So he is actually the person who coined this term algorithm, and because of this al-Khwarizmi, this algorithm word is derived. So algorithm is been in place to solve any problem. So normally when we say algorithm, algorithm is something a step-by-step procedure to solve any problem. But when we talk about computer algorithms, again it is a step-by-step procedure to solve a problem. But here we are solving a problem with the help of a computer. So algorithm is just a step-by-step procedure to solve a problem, and computer algorithm is if we are applying these steps on the computers to get our solution, then it is called computer algorithms. For example, whatever the task we are doing, whatever the problem we are solving, it's an easy problem or a difficult problem, we are actually following some sequence of steps to solve the problem. So if the computer is not involved, then it's not a computer algorithm. For example, uh, if I want to make a tea, okay, now for making a tea is also required a systematic approach. You need to follow step-by-step method to finally get your tea ready. But this is not a computer algorithm because here we are not using any computer to perform any steps. So before we go into the algorithms, we need to understand what are the properties of algorithm. So any algorithm, any step-by-step procedure is said to be an algorithm if it fulfills these five properties. So these five properties must be there for any good algorithm. So if you want to know that the given sequence of step is it a algorithm, you can just check all these five properties. If all the five properties are fulfilled, then that sequence of step is said to be a algorithm for any problem. Okay, so the first property is finiteness. Finiteness means that uh, there are definite number of steps to solve a problem. That means if you start doing any steps to solve a problem, it must terminate at some point. It must terminate, otherwise your solution will be going for indefinite number of times. So if this is uh, uh, seen in the algorithm like indefiniteness, then it is not a algorithm, it is not a kind of good algorithm, or even it is not algorithm, because all these 5 properties must satisfy to be an algorithm. So there must be a finiteness, means algorithm must terminate after a defined number of steps. Then the second is unambiguousness. Unambiguousness means there must be no ambiguity, means all the statement must be very clear. So it is basically reflects the clarity of the statements. So whatever the statements we are mentioning in our algorithm must be very very clear and there is no doubt. What does it mean? It means, let's say we have a problem P and we are going to apply some sequence of steps to solve this problem. Let's say the steps are A, B, C, D and E. So if I start from A and then go to B, C, D and E, I got my solution. This is, we are assuming this is a problem P and this is a solution. Or you can say our problem is we are at position A and we want to go to position E. Okay, and to reach here we have a defined kind of paths are available. So A, B, and then we have C, then we have D here, and this is how we can reach. This is a path given to us, and the problem is this is a starting point. We want to go from A to E. Okay, so what I am trying to tell is this unambiguous property. Now here if you see, I can go from A to B. This is very clear. There is no other path available. We can straightforward move from A to B. But at stage B, when you go to B, now here in the diagram we have two options, B and C. Now this is a ambiguous behavior. There is no clarity where to move. So if your algorithm is having this kind of behavior where at any steps you are not very sure what to do, then it is called ambiguous, and this is not a part of the algorithm. So algorithm must be having a clarity in the statement. And definiteness of the sequences. What does this means? Now there is a definite sequencing among the steps. What does it mean? It means if I am saying I am going to solve my problem P, and to solve this I need A, B, C, D and E, that means there is a proper sequencing among these steps. That means first I will do A, then I will do B, then C, then D, then E. I cannot say that I can solve my problem by using these steps. I will do A, then E, then B, then C, then D. Now this is not allowed. Means if you are having this kind of situation, then that particular set of steps is not an algorithm. So it must be have a definite sequence of steps. Then input output defined. For every algorithm which is for any problem, we have a defined input because we are designing an algorithm for a defined set of input. We must be very sure about what kind of input we are going to provide and what is the output we are going to get. So if input and outputs are not defined, then again it is not fulfilling the property of algorithm. Feasibility. Feasibility means it is possible to implement. Possible to implement means whatever the steps we are proposing in our solution, that is actually feasible to implement. Whatever the resources are required, whatever the constraint is given in the problem, that all are actually possible to implement using the steps which we are defining to solve the problem. So if your solution suggests any of the steps which is kind of imaginary, which is not possible or feasible to implement, then again it is not an algorithm. So if any set of statement is given to you and you are asked that is it an algorithm, then we need to check all these five properties, and if all the five properties are actually fulfilled, then we can say that the given set of statements may be an algorithm for a particular problem. So by keeping in mind all the properties of the algorithm, we can make a definition for algorithm. We can say it can be defined as a sequence of definite and effective instructions, which terminates with the correct output from the given input. So this is one technical definition that we can propose out of all these given properties. Now, when we are trying to solve any problem, we need to find an algorithm for that problem. Now, to devise an algorithm, we have different strategies. So you will see in the coming classes that what are the different strategies actually we are using it to solve a problem. But in this slide, I am just trying to focus on a very fundamental idea that what are the different strategies, what are the different approaches are available to solve different kind of problems. One thing to understand here that these are the strategies which have a kind of some very particular behavior. Each strategy have a defined behavior which makes them different, and these are not mutually exclusive. That means when we apply any of these strategies, you may find some of the features are overlapping. Some of the features we will find in, for example, in greedy method. Also, you can be doing in dynamic programming as well. I am just telling for you example. So some of the features may be overlapping because they are not mutually exclusive, but they have a very particular property that makes them different. So I will be just focusing on that particular part that makes them different, so that you can have a feel that what is this approach. So when we talk about divide and conquer, so divide and conquer means here we have a big problem and then we are dividing this problem into a sub problem. So the key idea is dividing problems into sub problems. This is called divide and conquer approach. So basically we are using this approach when our problem size is very big, and it is already been proven that in order to solve a larger problem, it is always good to divide the problem into the smaller parts, solve these sub problems, and then later you can combine these sub problems to get a solution for a larger problem. This is one approach. One important point to remember is these are the different approaches which is not applied to all kind of problems. In the real life, we have a problems, and the problems are of different kind of nature. And based on the nature, we need to identify which strategy is actually suitable. So dynamic programming cannot be applicable to all the problems. Randomized approach cannot be applicable to all the problem. So we have different criteria, we have different scenarios. Based on that, we need to identify what are the different approach we can choose for the given problem. Greedy method is also one of the very popular strategy to solve the problem. So in the greedy method, what we are doing is we are choosing the best among local choices. So the key idea of this is choosing best among local choices. Now, this type of approach will not guarantee for the solution. This is not guarantee for solution. You may get solution, you may not get solution, but it is not guaranteed. So later we will see that there are some methods where the greedy method is very good to find a solution. Now, one thing to understand that we have a different kind of problems. Sometimes we find a very quick solution. We want the solution must be very quick without bothering for its kind of reliability. Some problems are actually caring for a very perfect solution, and it will actually take some time to elaborate the problem domain very carefully. So uh, to understand in a proper way, we will take some case studies, we will take some scenarios where you can easily realize that where these methods can be best fit to see their kind of strategy. So greedy method is something where we are only concerning about the local choices, whatever the best option is actually available to you at that point of time. You just choose that step and then proceed. You are not caring for the entire scenario. You are not caring for the longer term, results. Then the next is the branch and bound. This is also a very popular approach, and in the branch or bound, the key feature is this, that successively when you keep on solving the problem, you will get a tree of sub problems. So I can write here, mm, successively a tree of sub problem is formed. So as we move toward the solution, we are actually getting a tree of sub problems. This is the key nature of this kind of strategy. Now backtracking. Backtracking is also being used in many problems, but the key uh, property that is used in backtracking is it is based on depth first search recursive approach. So if our problem allows us to backtrack, so we are trying to solve a problem, we are exploring the different possibilities to get the solution, and if at any point of time we are failing to get the solution, we can backtrack and then try for different possible solution. So this is the nature of this backtracking. It is basically based on the depth first search recursive approach. Now, dynamic programming is also one of the very efficient programming approach, and it always gives you the optimal solution, the best solution you can get. If dynamic programming is applicable in that scenario, then it will guarantee that your solution will always be optimal. Now, what is that? It basically stores partial or intermediate results. So solving, while proceeding towards the solution, in the algorithm, we are having some calculations, and these intermediate calculations are stored. So this is the basic nature of the dynamic programming. Brute force is a very common approach, and it is also giving you the optimal solution, but it is very, very time consuming. It gives you the optimal solution, it will guarantee the solution, but it is a very time consuming approach. And brute force, basically we are applying as a startup to find out the solution. If you are coming up with a very, very new problem which you have not come across, then brute force is the first strategy that we use to solve the problem. So in this, the idea is to elaborate all possible solution. So here we will just try to find out all possibilities to get our solution. Randomized is also one of the strategy. In the randomized, what we are doing, it takes random input during computation. So you have to keep in mind that these are the different strategies, approaches to solve different kind of problems. And again, I will repeat that these problems are not mutually exclusive. Many of the features are overlapping, but they have one key property that I have already discussed. So these are the key and nature of these strategies you have to keep in mind, and that makes them different. Later in the later classes, we will be discussing these strategies. We will take different kind of problems, and then we will apply these strategies. Okay, so here we are talking about algorithm. Algorithm is we are solving our problem using computers. So here when we solve any problem using computers, it has to undergo a defined sequence of stages. So it's a kind of you can say it's a life cycle of problem solving using computers. So we have a first stage and second and third and fourth, and this is how the life cycle is actually happening when you develop any software. So we'll go one by one. What are the stages of this life cycle, or you can say what are the different component of this entire life cycle of this particular program development. So the very first thing is the problem. This is very obvious because unless you have any problem means any task which we are willing to solve. So unless you have any problem, you are not going to you are not willing to propose any algorithm. So the very first thing is you must have some task in your hand. Task is anything. It can be anything which you want to solve. You want to communicate. You want to establish a connection between the two machines. Okay. You want to send some packet from one machine to many different machines. Okay. You want to sort a given sequence of numbers. Okay, you want to find out the largest numbers, you want to find out the least numbers, you want to remove the duplicates. Now these are the various different problems that you may think of, and all will be solved using computers. Now here we are looking about the algorithm. So the first thing is we must have a task. Okay, the task is, let's say my task is to search a number from a given sequence. This is my task. Then strategy. Once you identify your task, you need to think about the strategy. What strategy you are going to use to solve your problem. Strategy means, already we have discussed, we have different approaches like dynamic programming is there, branch and bound is there, greedy method is there, we have divide and conquer is there. Now, this is only possible when you have a good understanding of the problem as well as the good understanding of the strategy. Then only you can identify what strategies you are going to adopt. Now, this all comes with the experience. You must have an exposure. So slowly, when you start doing programming, when you take problems, when you explore the different dimensions of that problem, you will learn that what strategy will be good for which kind of problem. So it comes with the experience. So the first thing is you must have a knowledge of different strategies, and then you must have the kind of going through the case studies that which strategy is good for what kind of problem. Then the third stage is algorithm. Once you have identified the strategy, let's say I have identified that I am going to solve my problem using brute force, or I am going to solve problem using divide and conquer. Now I have realized that divide and conquer is very good for for this kind of problem. I know the nature of the problem, and I know the nature of the strategies which are applicable to different kind of problems. So based on that, I will identify my strategy, and then I will start developing my algorithm. So the third is algorithm. So when I say algorithm must consist of three parts: input, output, and steps. Input, you must be very much sure that what kind of input you are going to provide. Means the problem will take what kind of input, on what particular input you are solving the problem. When I say I am going to find uh, a particular number, so my input is a set of numbers. Okay, and I am going to provide a set of numbers, and then I am going to provide a particular number which I am looking for. So you must be very much clear about the nature of input, what is actually required to provide to the problem in order to get the output, and what is the output, what exactly you are looking for. So this is very important thing to be known to any program designer who is actually writing the algorithm for the problem. He must be very much sure about the input, what input he is going to provide to the program, and then what output he is expecting. Once these two things are identified, then the third is steps. Step means you have to find out what are the sequencing of the statements which is required to get my input into the output. So step is actually just a set of statements which is required to get your output. Then once you finish with the algorithm, you have finished with the algorithm, then the next is the analysis. Now analysis means you are now trying to identify the effectiveness. You are analyzing your algorithms, you are analyzing the effectiveness, that how effective is my algorithm. Now when I say effectiveness or when I say analysis, we are actually doing for three things. One is the time and space, optimality, and the correctness. In our course, most of the time when we do analysis, we are focusing on time and space part. Okay, this is the main focus in our discussion in the coming lectures. Optimality and correctness we are not discussing for all the cases, but we are discussing mainly these two things. But here we will understand what these terms mean. Time and space. So time basically time required to execute or to get the solution. How much time will be required to get the solution? This is called time required, and the space means the memory requirement. So how much memory is required in order to run the algorithm? So you have some sequence of steps which you have defined in the algorithm. Now if you want to run this algorithm, how much memory will be needed and how much time it will take to give you the solution? This is called time and space analysis. We are also using the term complexity. So in the later classes, when I say I am finding the time complexity, actually I am doing the time analysis. How much time will be required? If I say space complexity, that means I am doing space analysis and my interest is to find out how much memory will be needed. Now these are the two fundamental parameters that is actually used to find the effectiveness. This is also important because you may have n numbers of algorithms for any problem. How do you identify which one is a good one? For example, when I say sorting, there are a lot of problems out there, but I have taken sorting because sorting is something which is very familiar to you. You have been using it in your previous semesters. Now sorting, there are many numbers of sortings that are available. You have bubble sort, we have selection sort, we have insertion sort, merge sort, a heap sort, we have bucket sort, we have radix sort, we have tournament sort. N numbers of sorting methods are available. So which one is best? So how can you give the answer to this? Which one is best? So the answer to this is, one thing is, all sorting is not good for all kind of scenarios. We have a different constraints. We have a different bindations with the problem. Based on that, we will see which is good for us. But again, we have some general algorithms that is applicable to all kind of scenarios. In that case, how you will find out which one is good one? So you can do analysis. You will find that which algorithms require less amount of time, which algorithms require less amount of memory. So whichever will take the less amount is said to be efficient. This is very obvious. But most of the time you will realize that we will do trade-off. Trade-off means you need to decide which is your primary part, which is your prime focus, your time or space, because you may realize that most of the time the algorithm which take more time will actually take less space, and the one who take more space will maybe taking less time. So you have to do a trade-off. You have to compromise on one factor. So we will see which is good for our problem. It's again depending on the problem nature. We will see and then we will decide that this is good for our problem scenario. Optimality. Optimality means after designing your algorithm, you are now uh, giving putting more emphasis to make it better. You are trying to means more elaborating it to find out what is the scope of making it improve, make it more better. Okay, so that is optimality. So you will check, you will explore that whatever the algorithm has been proposed, is it giving you the best solution or there is further scope to get better than this? Is it possible to move with different strategy? Maybe you have chosen one strategy. Let's say you have chosen the brute force and you have proposed a solution, and then you get a solution, and then you may analyze it and you will say, is it possible if I go with the divide and conquer, can I make it better? Or whatever the data structures you have used in algorithm A, is it possible if I propose a new algorithm with a new data structures to get a better result? So optimality is you are trying to make it more better. This is the second step after proposing an algorithm. Then correctness means you are focusing, you are actually checking that whatever you did, whatever you have proposed, the output, you get it or not based on your input. So you are just checking the correctness of the algorithm. Then we have implementation. Is actually is a kind of program which you are writing. So it's a whatever you have proposed here, whatever you have identified the solution, now it's a time to write a program using some programming language. This is called implementation. Now for implementation you might be using any programming language. You can use C++, Java, Python, whatever language you are comfortable, you can do the implementation. And then the verification is basically kind of checking that whatever the result you are expecting from the software you are getting or not. It's a kind of testing, and for this we are developing a test article. We have different strategies are there, well-defined strategies are already in place, which is used to verify that whatever the output you are getting from your software is correct or not. In our course we are actually doing this part. Implementation we are not focusing, we are not writing a program to implement it, but it is always good. You can, whatever the algorithms we are studying, you can implement it and see its its output, how it is performing. But our main emphasis will be on analysis, and we are doing analysis for time and space. Okay, so after just observing or understanding all these steps of problem solving using computers, now we will take one example to realize that how all these steps will be fitted into any problem. So let me just revise, just recall all the steps. We must have a problem to solve. Then we will look for the strategy, that what a strategy we are going to use to solve the problem. Then we write the algorithms, and the algorithms we must be sure about the input, output, and then the steps. And then we are going to analyze. In the analyze, we are actually doing three activities. We are doing the analysis of time and space. We are also looking for the optimality. We are also looking for the correctness. And then the next step is implementation, and the next is verification. So we will start one by one, and we will take one case study, one scenario, and then we'll see how all these steps will be implemented. So let's say our problem is to search in an unsorted array. We have given one array, let's say 2, 5, 1, 7, 6, 12. This is one array given to us, and we are interested to find one element. We are looking for one element out of this. Let's say we are looking for 7. This is the problem. Now already you know what is a search, linear search. This is called linear search. It's a very fundamental algorithm for searching any element from the array. Already you have done this, so I'm just going through it very fastly because there is no need to explain all this logic. So this is the problem. Now we have a problem. Okay, then the strategy we have defined is a brute force. Okay, brute force means we will apply all the possibilities. Means we are searching individual element. I'm looking for 7. I will say, is this 7? No. Is this 7? No. Is this 7? No. Is this 7? Yes. This is my solution. This is called brute force approach. So when I start writing an algorithm, I have started with the brute force approach. So I have a problem, I have the strategy. Now the third step is the algorithm. In the algorithm, so we have this problem, and problem we have defined that this is the idea, right? strategy we have find out. So it's a brute force strategy, and what we are doing is we are searching every element with every other element to see that our required element is there or not. If it is found, we will return the index of this element, and if it is not found, we will return -1. This is our strategy that we have find out. Next step is the algorithm designing. So in the algorithm designing, we need input, output, and the steps. So in the input, we need to find out, make it very clear that what actually we are going to provide in our program. So in our program input, we provide the array. This is our array. We provide the size of the array, and we provide the element which you are looking for. So these are the three input which is required to be provided to the algorithm to get the solution. Similarly, what is the output we are expecting? We are expecting, if the element is found, we are looking for the location. We want the index at which position that element is actually existing. If it is not found, it will return -1, something like this. So this is the output. So we have our input, we have output. Now what is required? We require the steps. Steps means the logic, how we use this input to get the output. So this is the algorithm for linear search. This is kind of, we are given one procedure. We have a procedure will take three inputs, which is array, the size of the array, and the element which you are looking for, and it will return the integer value. It is a index. It's the index. If element is found, it will represent the index of that particular element. If element is not found, it return -1. So initially we are using that ANS. We have used some variable. Now this is the logic that is already known to us. So this is how the things are actually done. It means done. These are the steps of the algorithm. I am just skipping it. I am assuming that you have already uh, familiar to this algorithm. If you are not, then you can write to me and I will explain you. Then comes analysis. So in the analysis, we are actually analyzing how much time it will take to to execute to get the solution. So here we are actually focusing, when I say analysis of the efforts, so here we will be focusing on uh, just a minute. So here we will be focusing on amount of work done. This is actually effort. Okay, so here we are, this is actually, we are called time analysis. Okay, so when I say amount of work done, what are the effort required to get the solution? Now to find this amount of work done, we need to just a minute, it's not working. Okay, so I think there is some problem in this software. I think it's not working. I will check it later. Okay, so we are talking about the amount of work done. So amount of work done means we are interested to find out the effort required. Now, how much effort is required to execute this algorithm? Effort required by the computer. Okay, so to find out the effort required, we are basically we are looking for the basic operation that we are doing in our algorithm. Now when I say basic operations, so for simplicity, I will tell you the very fundamental operations that we do most of the time. One operation is you are shifting the element from one position to other position. You are moving from one location to other location, or you are swapping the two elements among themselves, or you are comparing. So most of the time you can take any algorithm and you will find that these are the fundamental operations that we are doing inside the algorithm. So here we need to find out what fundamental operations we are doing in our algorithm, and then we will see how many times we are doing this operation, and that will define the amount of work done. This will define what is the effort required. So in our case, we are doing comparison. So what we are doing is, we have a set of elements, we are looking for one element, so we will compare, is the first element is the element which we are looking for? Yes, then stop. If no, move to the second element. Is the second element is the element which we are looking for? That means we are comparing. So the comparing is the fundamental task that we are doing. So we are doing this comparison task effort. So we will see how many times we are performing this task, how many times we are doing this comparison, and that will give you the total cost, the total amount of work done for this kind of algorithm. Now, to represent all this calculation, we will be using some notations. Let's say wn via function. So wn, I am using the word w. You can write anything, because here I am trying to find out the worst case. So later in a lecture of asymptotic analysis, we will be getting more about the worst case, average case, and the best case. But here I will just give you an idea that worst case means it will give you the maximum effort that is required to perform this algorithm, means the maximum number of steps, the maximum number of comparison that is required to get the solution. So that means the worst case. Worst means the maximum effort that is required to get the solution, the maximum amount of work that you are going to do. So wn via function, and wn is the maximum number of basic operations performed by the algorithm on any input size n. So here the n is the size of your input. In our case, we have an array of size n. So wn equals to n, because at most you are going to, excuse me, so at most you are going to compare n number of times. For example, I have an array which consists of 7 elements, and I am looking for a particular element. Then I will be going to compare at most 7 times. I will check, is the first element is the one which I am looking for, is the second element is the element which I am looking for. So at most I am doing 7 comparisons. If the element exists at the last position, then also I am doing 7 comparison. If the element not exist, then also I am doing 7 comparisons. And after doing 7 comparisons, I will stop and I will realize that the element is not existing in my array. So 7, if the size is 7, then the effort is the 7 comparison. But if the size is n, then the effort is n. So wn means the worst case, the maximum comparison required for input of size n is n in our case. So here the effort is n. Now the next part is the optimality. So if you remember, we discussed that in the analysis we are doing the analysis of the time and then the optimality. Optimality means we are trying to find out the scope. We are trying to find out, is it the best solution, or we have a scope to make it better. So in the linear search, if you do more study, you will find that yes, you may realize after more studying the scenario, you may say yes, we have used the brute force, but if the list is sorted, then we don't apply the brute force, we can go for a divide and conquer approach. And when we do divide and conquer approach, we can get a better solution, and we call it as a binary search. So I think you all are actually familiar about binary search, how to apply binary search. And the running time of binary search is log n. So here the most number of solution, the maximum number of not solution, the maximum number of comparison is log n. So here the running time is log n. In the previous case, running time is n. So log n is a less value than n. So this approach is better. But the only requirement is here your list must be sorted. So this is the optimality. Here we are exploring how we can make it better, or what are the cases where the algorithms can be performing better results. Then the next is the correctness. The correctness is the third part of analysis. Here we are proving the correctness of procedure. Whatever the procedure we have applied in our algorithm, are they correct or not? Now to perform this task correctness, there is a defined strategy. So you might be knowing that algorithm consists of a sequence of steps which consist of operations, instructions, statements, and we are actually transforming our input to output. We are calling it a precondition to postcondition. So if we satisfy all the precondition, and if you satisfy all the preconditions which is mentioned in the algorithm, and you get to the post condition, your output, whatever the inputs you have predefined. What if you fulfill all the conditions of the input, and if you are able to reach to the output, then algorithm is said to be correct. So this is or you can say another way, if the preconditions are satisfied, then the post conditions will be true, and then the algorithms will be going to terminate. And this is a strategy for doing the correctness check. Okay, then the next step is the implementation. So how we are going to implement, we are going to implement using any programming language. So you have already studied Java or C++, I guess, so you can use any of these language to implement all your programs or your algorithms. So in the algorithms, when we say, we are using a term called pseudocode. Now pseudocode is something which is written like an English like language, but we are not concerning about the syntax. When you write a program, in the program you are very much concerned about the syntax, because if the syntax is not correct, you will get errors. But in the algorithms, we simply care for the meaning of that statement. Okay, if I want to add two numbers, I will say add a and b, or I say add two numbers, or I will say c equals to a plus b. This is my notation to represent that I am interested to add two numbers. But in the program, you need to follow the syntax which is there in the programming language. So pseudocode is just a representation of the meaning of the statement, and that we are using in the algorithms. But then you have to convert the pseudocode into the program syntax. The next step is the verification. Verification means you need to verify your result. Means when you run a program, you get some output, and then you have to check that this output is correct or not. For that, we have a defined strategy of testing. We have different test oracles methods are there. We will make some sample cases. We will run our output into that cases to check its efficiency. So this is all about the algorithm stages, different stages of algorithm, and the basic introduction of algorithm. In the next lecture, we will go more deeper into this subject. We will see what else is there, and there is so many things are there. And I hope you will finding interest in this course. It is very important course in computer science. And believe me, if you want to be a good programmer, you cannot escape from this course. You cannot escape this. You have to develop interest. Otherwise, you learn any of the language, you cannot claim you as a very good programmer, efficient programmer, unless you have a knowledge of algorithm. Okay, thank you very much. See you in the next lecture. Bye for now.